In this video, we're going to talk about the three intermolecular forces, and the first one is London forces. London forces is basically a surface area interaction. So the bigger your molecules are, the more interaction they can have with each other, and the stronger that force will be. So the way we're going to estimate the size of our molecules is based on molecular weight or molar mass. Those terms are used interchangeably, which we figure out by adding up the mass of each individual element. So for NH3, if you look at the periodic table, the mass, in this case we are using the decimal numbers that are written on the periodic table. However, you are welcome to round. I round just about everything to the whole number. At the periodic table, nitrogen is about 14 grams per mole. Hydrogen is about 1 gram per mole. But I've got 3 of them, so I need to take that 1 times 3. So here we're going to have 14 plus 3 is 17 grams per mole for our molecular weight, molar mass. Sulfur is 32 grams per mole, plus the oxygens, which are 16 grams per mole. And I've got 3 of them, so we'll take that times 3. If we add all of that up together, we come up with 80 grams per mole. HCN, hydrogen, 1 gram per mole, plus carbon, which is 12 grams per mole, and nitrogen, which is 14 grams per mole. Add that together and you end up with 27 grams per mole. Then the last example, carbon is 12 plus 3 for the hydrogen, 1 times 3, right? Plus 19 for fluorine. So 12 plus 3 is 15 plus 19 is, oops, not 24, we get 34 grams per mole. So now to rank London forces from weakest to strongest, we're going to rank our molecules from smallest to biggest. So this means that nitrogen, or sorry, the NH3 is going to be weaker London forces than the HCN, which is weaker than CH3F, which is weaker than SO3. The next force we're going to look at are dipole forces. Dipole forces are going to be connected to any molecule that is polar. So we're going back to earlier in the chapter when we were deciding if a molecule is polar or nonpolar. If it's polar, it will have dipole forces. If it's nonpolar, it will not. So many of these we've already looked at and decided if it's polar or nonpolar. NH3 was polar. SO3 was nonpolar. HCN was polar. CH3F we didn't do, so we're going to look at that one real quick here. So 4 bonding groups, no lone pairs is tetrahedral. And while tetrahedral is not flat like this, the idea of thinking about the surface, drawing your circle, works if you keep it flat, kind of by coincidence, but that's okay. So we notice we have hydrogen and fluorine on the outside, so because things are different, that's going to make it polar. So that means the molecules that are polar will have dipole forces. And the ones that are non-polar do not. The last intermolecular force we're going to talk about is hydrogen bonding. Hydrogen bonding is going to occur anytime you have a molecule that contains a hydrogen fluorine, hydrogen nitrogen, or hydrogen oxygen bond. So if one of those bonds exists within your molecule, you have hydrogen bonding. So you do need to have a at least a Lewis structure partially done so you know what atoms are connected to what. So again, we've seen most of these. So NH3, we have hydrogen attached to nitrogen, so there is hydrogen bonding. SO3, I don't even have hydrogen, so I don't even need to worry about structure. The answer is no. HCN was attached, H, then C, then N. So while we do have a hydrogen and nitrogen, they're not attached to each other. So there is not hydrogen bonding. CH3F, we have hydrogen and fluorine, but if we remember what the Lewis structure looked like, the hydrogen is not attached to the fluorine, so it also does not have hydrogen bonding.